Let's talk about empty and universal relations today. So suppose we have three students. There's Khan, there's Adi, and there's Ishan. And all of them are in 10th standard. They're part of a group and they have to do a group project that none of them want to do. But they've just learned relations and maths. And now they play a little game among them. The game is they try to make meaningful relations to find who among them will do the project. So Ishan, being the smallest in height, he very cleverly comes up with the relation. That relation would be AB when A is same height as of B. So Ishan, being the smallest in height, he will not be considered, whereas Adi and Khan are of the same height. So these two would be there in the relation. So we have Adi and Khan, and the relation would look like Khan Adi or Adi Khan. The order doesn't matter, right? So this is a relation, and this is a meaningful relation because out of the three people, two people are easily segregated out. So this is a meaningful relation. Now it's Khan's turn to make a relation. Relation Khan makes is R is equal to AB if age of A plus age of B is less than 50. Now think about this. All of them are in 10th standard. Their age can't be more than 15 or 16. So sum of any two ages would definitely be less than 50. So in this relation, I can take any two pairs of any two students, whether Khan or Adi, Ishan or Khan, or Adi or Ishan. So the relation that would be formed now would be, we have to take all three here, and we have to take all three here, just so we can conveniently write all the pairs that can be formed. So that's Khan, Adi and Ishan. There's also Khan, Adi and Ishan. So the pairs that can be possibly formed would be KK, which is Khan with Khan, Khan with Adi, Khan with Ishan, Adi with Khan, Adi with Adi, Adi with Ishan, Ishan with Khan, Ishan with Adi, and Ishan with Ishan. And this would be the set of all the pairs that can be formed, right? So this would be a relation. But this is, in general, the relation that whatever pairs that can be formed among them, right? So this would be the complete universal set of all the pairs. So this is the relation that Khan has made. So Adi's relation is R is equal to AB. It would be considered if A is a sister of B. Now, if this is a meaningless relation, then this is a even more meaningless relation, simply because all three of them are boys. So there can be any sisters here. So the elements that would be here would be none. It would just be an empty set, right? And think about these relations, this one and this one right here. In this, all the elements are there. Whatever can happen, all of them are here. And this relation contains none of them. So are these meaningful relations? Did they create any value in segregating them? No. Simply because they are too simple. One has taken all the elements while other has taken none of the elements. That's why they are called the trivial relations. Trivial simply means they are too simple. Now let's talk about them in detail. So let's talk about universal relations. So a universal relation is when a relation R in a set A is called universal relation if each element of A is related to every element of A. Now that is the relation we just saw. That is the relation that Khan had made to have all the elements. So suppose we have a set A containing three elements, 1, 2, 3. Then the universal relation on it would be when we take that set A with itself and we connect all the elements that can be connected. So 1 would go with 1 would go with 2, 1 would go with 3. Again, 2 would go with 1, 2, and 3, and 3 would go with 1, 2, and 3. So the number of pairs that can happen here would be R is equal to 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. So this is literally all the pairs that can happen between A with itself. That is the universal relation, right? So a simpler way to write this would be A cross A, because all the elements of A are made a pair with all the elements of A itself. So it is written as A cross A, and this is what we call the universal relation on A containing all paired elements. Now let's talk about empty relations, which is the relation that Adi had made. So empty relation is a relation R in a set A? Well, no element of A is related to any element of A. So again, if we took our set A containing 3 elements, 1, 2, 3, then the relation that doesn't relate to any elements, and such a relation would contain no elements, that is an empty relation. So it can be written as this because it contains no elements, because no element is related to any other element. So this is an empty relation containing no elements. And it can also be written as null set. This is the sign for null set, which means that it has no elements. And since null set is a subset of every other set, so it can also be written as R is equal to null set, which is a subset of A cross A. Now here, this A cross A is what we saw earlier. It is the universal relation on the set A containing all paired elements. And now if you ask why is null set a subset of every other set, which to be honest, it doesn't make that much sense. But on the technicality of definition, it does find its place, which is it is called a subset. Any set is called a subset when all the elements of that set is contained in the larger set. Since null set has no element, it is also by technicality contained in the larger set. Or a better way to understand it would be to ask yourself, is there any element in the null set that is not there in A cross A? Now, since null set has no elements, there is absolutely no answer to this. So that's why on a technicality, we do consider that null set is a subset of every other set. So this can be written as this. The empty relation can be written as this, since null set is a subset of all sets. Now let's take some examples to properly grip the concept. So we have examples, and let's take a relation defined as xy when x plus y is less than 0 on the set of natural numbers. So natural numbers are just positive integers, not even 0, just the positive integers. So the addition of two positive integers can never be less than 0 because none of them are negative. To get the addition be less than 0, there has to be at least one negative element. But since all of them are positive integers, so on this set, this relation would give us no elements, since no natural number is less than 0. And thus this is an empty relation. Let's take another example, defined just opposite of this relation, x plus y greater than 0 on the set of natural numbers. Now these are all positive integers. You can pick any two integers out of this, you can pick any two natural numbers, and its sum is inevitably going to be greater than 0. Right? And it can be just 1, 1, 1, 2, 1, 3, or any pair. Any two elements can be picked out. So I can simply write this as R is equal to n cross n, because any element of n can be paired with any element of n. And when this thing happens, this is what we call a universal relation, as we saw. This is a universal relation on n. So this relation is a universal relation. So that's all for today. Thank you.